Section 3.6 is solving multi-step inequalities. I can solve multi-step inequalities. That's our learning target and what we're shooting for. So in example 1, it says a school soccer team is trying to break a school record for goals scored in a season. The team has already scored 88 goals this season. The record is 138 goals. With 10 games remaining in the season, how many goals on average does the team need to score per game to break the record? So here, the amount of goals for the season is going to be what they've already scored plus what they will in the future. And they're trying to beat the record. So in order to beat the record here, they want more than 138. So what they've already scored is 88. We want to know, what does their average have to be for the 10 games? So we're going to add 10 times the number of goals they score per game. Because we're talking about how many goals per game do they need to score. And we still want that to be greater than the 138. So whatever their average is, we take that times 10, because there's 10 more games, to get that future number of goals. So what I'm really looking at here, and I'm just going to rewrite it so it's a little bit neater, is 88 plus 10g is greater than 138, because again, they want to break that record, so they want more than that. Okay, so here, my variable's being multiplied by 10 and added by 88. And just like with equations, we get rid of any addition or subtraction first. Again, solving inequalities and solving equations are very, very similar. The only difference is if we multiply or divide by that negative number, we have to flip our inequalities. So here, I'm going to get rid of this positive 88 by subtracting 88. Whatever I do to one side, I have to do to both. I didn't change my 10g or my inequality. When we add or subtract, we never change our inequality. But what I get here is 50. Now, g is being multiplied by 10, so I go ahead and get rid of multiplication by dividing. And since I divided by a positive number, I can keep that inequality. So here they're going to have to score an average of just over 5 goals a game. So anything more than 5 will give them a record. If they only score 5, though, they'll tie. So at least one game they have to score more than 5 and 5 every others. Somehow their average has to be more than 5. So here, we always want to make sure that both expressions, when we start off with, are completely simplified. So we have a left expression and a right expression. Both are as simple as I can get them, so now I can start solving. Here, we always want to get rid of anything not attached to our variable first, any addition or subtraction. I have subtracting by 6, I get rid of that by adding by 6. And if I change one side, I have to change both. I didn't change my x divided by negative 4, but negative 6 plus 6 gives me 0. Negative 5 plus 6 gives me 1. And since all I did was add here, I didn't change my inequality. Now, my variable is being divided by negative 4. So I can get rid of division by multiplying by negative 4. If I change one side, I have to change both. Anything divided by itself is 1, and 1 times x gives me just x. 1 times negative 4 is negative 4. And now, since I multiplied both sides by a negative 4, I have got to flip my inequality. And I get x is less than or equal to negative 4. If I plug that back in and check, we will be right. I checked both the boundary point and our inequality, and both are true. Now feel free to pause here and give this a try. G is being divided by negative 5 and added by 2. I get rid of or subtracted by 2. I get rid of subtraction first by adding. And if I change one side, I have to change both equivalently. Negative 6 plus 2 gives me negative 4. Negative 2 plus 2 gives me 0, which is perfect. since all I did was add there, I did not have to change my inequality. Now, g is being divided by -5, so I get rid of division by multiplying. So I'm going to go ahead and multiply both sides by -5. Negative divided by negative gives me a positive. -5 divided by -5 gives me 1, and 1 times g is just g. Now, since we multiplied both sides by a negative, I have got to flip that inequality. And I have 20 is less than or equal to g. Here I checked both our boundary point and our inequality symbol, and both gave me true statements, so we are correct. You plan to go ice skating often this winter. The skating rink charges $4 for admission. You can either rent ice skates at the skating rink for $5 per day or buy your own pair for $45. How many times do you have to use the ice skates in order for the cost of buying them to be less than the total cost of renting them? So here we want buying to be less than renting. So our costs for when we go, if we are buying, are still going to be $4 per time. So it's going to be 4 times the number of times we go, which I'm going to do X for the number of times, plus $45, because it's going to cost us that to buy them. To rent, okay, it's going to cost us $4 to go and $5 per time. So plus $5 per time. We want to make sure both expressions are as simple as we can get them. So here I have 4x plus 45. 4x plus 5x, so I can simplify, combine like terms, and that's 9x. Here I have variables on both sides, so I want to go ahead and solve. And it's more important with inequalities than it was with equations that we move the smaller one, so we don't have to divide by negative numbers as often. 4 is smaller than 9, so that's what I'm going to move. I get rid of it by subtracting, and whatever I do to one side, I have to do to both. 4x minus 4x, just like if they were regular 4 and -4, still give me a 0, even with that variable there. 9x minus 4x gives me 5x, and I didn't change my 45 or my less than. Now, my variable is being multiplied by 5. I can go ahead and get rid of that by dividing. And 9 is less than the number of times we have to go. We can rewrite that. Alligator right now is eating the x. We want to keep it eating the x. 9. So we have to go more than 9 times. So at least 10 times in order for buying them to be more cost efficient. And that's all I have for section 3.6.